All right. Hello, everyone. This is going to be the last episode in the self study physics series. And in this episode, I'm just going to give you some practical advice on how to actually get started with this type of study plan and this type of self study project. So, I'm going to give three pieces of advice, and I think two of them are applicable to basically any um, self study subject, whether you're learning physics or maths or computer science or languages or history or whatever you're studying. Um, and then one of them is more practically related to actually studying physics. Um, so I think the first piece of advice I want to give you is to start out small with developing a study habit. So don't tell yourself, I'm going to study 2 hours a day, every day, an hour calculus and an hour classical mechanics every single day. That's probably too much for most people. Especially if you haven't studied in a long time, you haven't been in school for a while, it's probably a lot better to start out with something like, okay, I'm going to do 15 minutes maths and 15 minutes physics. Um, or even just 15 minutes maths, don't even start with the physics yet. Then bring in the physics after a couple of weeks and build it up. Because you don't want to burn yourself out and make too big a commitment and then not actually follow through on your study goals. And then you feel disappointed and demotivated and um, you won't actually want to do it anymore because it'll feel like a chore because you're doing too much. You need to build up your studying stamina and then work towards bigger goals. Okay, so that's true for pretty much any subject you want to study, but that's the first piece of advice. The second piece of advice I'm going to give is, um, well, basically, what you need to keep in mind is that this is a long term project. This is something that's going to take you years and years and years to work through the program I laid out. Think about it if you're an undergrad student, you're going to spend, depending on your country, 3 or 4 years studying some of these topics. I haven't covered everything you do in an undergrad degree, just what I think the core areas are. But when you look at it that way, you're only studying as a part-time student just a little bit. And I would say you can learn things faster studying on your own, but this is a multi-year project, really. And you need to be patient and realize that, basically. Also, there are going to be times when it's frustrating. There are going to be times when you get stuck on a really difficult problem. There are going to be times when you just don't get something and it's really frustrating. But it's a lifelong, long term project. Physics is a very deep and rich subject, as is mathematics. And studying these subjects is really hard, but it's also worth it. And if you stick with it, you'll reap the rewards eventually. Now, the last piece of advice I just want to give you is to do with doing exercises and problems from textbooks. And here I kind of give generally two pieces of advice, which is don't do all the problems and don't get stuck on problems. And there's actually a third one, which is only do problems you have solutions for. So when I say don't do all the problems, I mean most textbooks give lots and lots of problems. Some don't. Some have a more sparse array of problems. But most textbooks give lots of problems, but not all of them are entirely essential for actually understanding the content of the textbook or for understanding the subject. Um, some textbooks, in fact, give you a list of what they consider the essential problems in the book. I'm thinking like Griffith's Quantum Mechanics labels certain problems as essential, others as very easy, or others as sort of peripheral and not that important. So that's something to keep in mind. You don't have to do every single problem in a textbook to say that you covered the textbook or that you understand the subject now. To do enough that you feel you have an understanding of how to solve some problems. And once you've done that, once you've done the essential stuff, then you can skip ahead to the next chapter. You don't have to do every single problem. If you want to, you can, but I think it'll bog you down a little bit and sort of slow your rate of progress. It's not really necessary. Speaking of getting bogged down, that brings me to my second piece of advice, which is do problems you actually can do. If you find a problem that's really, really hard and you can't find help for it and there's no solution for it, don't spend hours and hours on it. Just say, this problem is really hard, and move on to another problem, or just move on to the chapter. If you get stuck on something for too long, again, not every problem is essential. So if you get stuck on something for too long, it's going to frustrate you and it's going to slow down your progress, and you're going to be demotivated to get up and study every morning or every day, because, well, you don't want to just do the same problem over and over again and not be able to solve it. So just skip it. I know some people might disagree with this advice and it might sort of freak out some people, but I do think it's necessary to just say, do the problems you actually can do. You don't have to do every single problem. And then lastly, I would say only do problems you actually have a solution for, or at least an answer, because, well, you can't just ask a physics professor if you're studying at home. If you're in university, you can ask an expert, but you can't really do that at home. So I think it's better to really just do problems you have solutions for. Pick textbooks that have solutions manuals or that someone has posted solutions of on the internet. And yeah, because you want to be able to check your work. Anyway, those are 3 general pieces of advice and the end of the series. So if you've watched all of the videos, thanks for watching. You can like and subscribe if you want more videos like these. Okay, bye.